Okay, this video is going to help you for lab number 9, where you're going to be constructing another template just as we did in lab 8. In this case, we're going to be constructing a template to calculate the size of a separator you'll be needing for a particular application. You're going to be given the input values, the input for first, you're going to be given the flow rate for the gas flow rate. Now you need a separator that can handle, that has enough capacity to handle both the liquid and the gas. So we are designing for both. Now I will explain how the template works, how the calculation works. First of all, you calculate the size of the diameter based on the gas flow rate. Then you will check whether which of them can handle the volume, the liquid. Okay, now so these are the given numbers. You have the gas flow rate, the specific gravity. Then we need to know the specific gravity for the condensate too, and the flow rate for the condensate. That's the capacity. Then the pressure, temperature. And here we're gonna need the compressibility factor. I think the best thing is to first of all go find the compressibility factor. Don't forget, don't just leave any number there. You have to find the compressibility factor based on your given values there, based on the specific gravity of the gas, 0.7, and then the pressure and temperature. So let me go do that first. I'm going to open the Brilbeck's template. Brilbeck's. See, I put this pressure, the temperature, the specific gravity. Then since you are not given the mole fraction, so you put 0 for all of them, all the 3. Then you read the compressibility factor, which is 0.8522. You copy it, then I'm going to close this now. Then I come here, I do paste space what? Values. Paste values. Okay. So that's it. So I've completed all my input. Don't forget, you have to get that compressibility factor first. Okay. So now here is where you select the type of separator you want to calculate for, whether you want to use. 1 is for vertical, 2 is for horizontal, and 3 is for spherical. So just as we did for lab 8, we're going to have to put formulas in. In fact, you don't have many formulas to put here. The first one is the operating temperature. So that is equals. I want to express it in Rankine. So I click on the temperature here. Then I put plus 460. Then the next one is the gas density. Gas density, we calculate, this is the formula there. We did that in chapter 2, where we were talking about properties of gas. So I'm going to do equals 2.7 multiplied by star what? Pressure. So I click on the pressure, then multiply by what? Star specific gravity of the gas, which is 0.7. I click on that. That would be C13. Then what? Divided by slash. You see why we need to get the Z first. Divided by Z. I click on Z. Then slash. Oh, my mouse is misbehaving. Let me go back there. Slash. Where's the last thing? Divided by Z. I click on Z. Then slash. Again, temperature in Rankine, which is this C22. Okay, so that should give me my density. There's something wrong with 2.7 multiplied by 616. 616 is what? That's the operating pressure. Then multiplied by gamma, which is C13. Then divided by C18, which is Z. Then divided by C22, which is the temperature. So why is it putting here 30 there? Okay, maybe Excel is not running. I'll just have an F9. Okay, so this one, the density for liquid, that is, you have that there, equals 8829.6 divided by slash. Then I'm dividing by 131.5 plus API, so I have to put it in bracket. 131.5 plus, then I click on the API gravity, which is 60 here, C15. Then I close the bracket. Okay, that one calculates. What's wrong with my... Oh, okay, I think, let me check the... Okay, it's not that. Why is it 0? Okay, I'll find out later. Then the next thing is to find the K value. Okay. K is a constant you find in this to find D. So the K is K is gonna be constant. If it's vertical, you use 0.205. If it's horizontal, you use 0.45. Then if it is spherical, you use 0.325. So we're gonna put if statement there. Equals if I open the bracket. So where do I read the type of separator? I'm going to go here. That's C19. So if C19 equals 1, if C19 equals 1, I put comma. So what is it going to do? It's going to use 0.205. Otherwise, I put another comma. Otherwise, now I still have to test for 2 now. So I'm going to use another if there to test. Wait, I didn't put comma here. This is not. That's not comma. Okay, otherwise. I'm putting too many things. This 0. Okay. Now, otherwise. So I'm now going to test whether it's horizontal or spherical. So I'm going to put another if there. If, you don't need to put equals again because your equals is at the beginning. So I'm going to do if. Now to choose between 2 now. If, I'll go back to that. If this cell, C19 again, equals 2, comma, then that is horizontal. So that should be 0.45. Otherwise, there's only one option left. Otherwise, you put 0.325. It means it's spherical. So I close this if. Then I close the overall if, the last. So 2 bracket ends it. So you see it's selecting 0.205. because I put 1 here. Let me test it. I put 2, it's going to be 0.45. Okay. I put 3, it's going to be 0.325. That's correct now. So now the next thing is to find the condensate flow rate. The condensate flow rate is depends on the condensate ratio. This one says 80 billion per million standard cubic feet, and I have 5 million cubic feet of gas. So it's going to be equals. The condensed flow rate will be equals the rate there. I click on that, C14 multiplied by C12, which is the gas flow rate. So in this case, it's 400. If I change the number, it will change. So now the final two, that's really what we want. The separator diameter and the VL. The VL is easy. It's just the liquid flow rate, which we just calculated, divided by 1440. I can actually do that now. Here is going to be equals whatever I calculate here, the condensate flow rate divided by 1440. Okay. So in this case, 0.278. Okay, that's the settling volume. Now let's calculate the D. That's the major thing there. We calculate the D based on the gas capacity. Just remember that. Okay, we calculate the D based on the gas capacity, and the formula for D is given here. So let's follow the formula. Just follow it. Equals. So everything is square root. So I'm going to do square root. SQRT. I open the bracket. I'll do the top first. That's Q. That's the gas flow rate. Okay, that's the gas flow rate. That's C12 multiplied by star Z. See why we need the Z? We need the Z twice for the density and for. Then multiply by again T. When you are calculating gas, you always have to use the Rankine. So C22. Now then divided by, I've done all the top. Everything at the bottom should be slash slash slash. So slash 2.4 slash K. I just calculated that. K is C25. I click on that. Then slash pressure, which is 800, C13, C15. Then slash. Now, slash what? Square root of. So I have to put under SQRT. Don't forget, I've not closed the first bracket. So I open this one again. Now I have density of liquid minus density of gas divided by density of gas. So I have to put density of liquid minus density of gas in bracket. Otherwise, so I will open another bracket. Density of liquid, which is this one, C24, minus density of gas, which is, that's a problem here. I have to find out what. I click on that. I close that bracket. Slash density of gas. I click on density of gas again. So then I close the. Okay, I've closed the first bracket. Then I close the square root bracket for the internal one. Then I close the other square root bracket, the first one. So that should be okay. It's going to give me division by 0 because something. I will check this one now. So we've put all the formula. That's all in it. Now let me see what's going on there. The density of this gas density. Let me start all over again. I don't know why it's putting 0. Something is wrong there. Equals 2.7 star pressure. I click on pressure, then star again, gamma, which is specific gravity of gas, 0.7, unless there's a problem there. Okay, then divided by backslash z. I click on z, then divided again by backslash t. Rankine. If there is no problem, this should be okay now. Good. 3.28. Now you see. Oh, this is a very. Oh, I didn't finish this. This is feet. The separator diameter I calculated as feet. Then I have to, after I close the square root bracket, I have to do star 12 to convert it to inches. Don't forget that after I'm talking about the diameter, you have to finish it by star 12. So that's it. So now this one is okay. So that is the formula there. You can read it. So this is 12. Okay, let's analyze this now. Supposing I have this, I'm going to look for, check for each case, check the size of the, let's start with the variable. I put 1 there. Variable 1. So the first answer, which is the diameter, gives you, that's the minimum diameter of the separator you need. Then this one means this one must, both of them must be satisfied. So let's look at for variable now. Minimum diameter is 15 inches. Then the volume certainly must be at least 0.278. So I go to the table here. You see the table on the right? Now this is vertical, the next one is horizontal, the next one is spherical. Now for the vertical, I'm looking for 16. Okay, I got 16. But what matters now is the 0.278, which is the retention. Okay, this first one is 0.27, so that one is not going to work. So I have to use this. So this is the size I need. You can do up to 0.41.